Texellent Heating and Cooling. Custom air service is our specialty. Heating and cooling and indoor air quality. Let's talk heating and cooling with your specialist, Terry McWilliams and Mike Landry.
Welcome back to Texellent Heating and Cooling's podcast series. Today we're going to be talking about indoor air quality. We've got Terry McWilliams with us. He's the owner.
Hi, how's everybody doing?
What's happening, Terry? Now, just so you know, this particular episode is focused on indoor air quality technologies and remedies to help you understand what some of the challenges are you might be facing in your home, maybe even symptomatic issues that can be resolved with simple technologies and simple changes to your air conditioning system without actually having to rip it out and change it out. So today we're going to focus on three aspects of indoor air quality, and this is to help you understand what this technology does and stay away from things that are, talked about a lot, sold a lot, but really have little impact or benefit. Okay, so we've got proper design. This is a big deal. If you're getting your system replaced because it failed, you need to understand what proper design means. We're also going to cover ducting in this episode. Advanced filtration is the next category, and then supplemental dehumidification and ventilation. Now, these terms are foreign to you, but they'll make sense to you here in a second. So, Terry, let's talk about proper design. You've been living in the house. It's 20 years old, 15 years old, whatever. And the system, one of your systems went down, and now you have to replace it. How does proper design come into play with that? I mean, the guys that are coming up to your house, knocking on your door, going up in the attic, they're just going to look at your 3-ton or your 4-ton, and then they're going to quote you on replacing that. Why isn't that enough?
Because there's a variety of things that could change in the home over the course of its life. If it is an older home, someone at some point could have oversized the system because somebody was having comfort issues that they didn't know how to properly address. So you want to not only look at what's existing there, but you want to ask questions to the current homeowner, especially if they've been through several seasons with that air conditioning system, as to how its performance was in those heavy seasons. And you also want to do some measurements yourself with manual J, manual D, manual S, to be able to scientifically prove, like, hey, according to these calculations, this size house, this construction, you need this capacity system to properly heat, cool, and dehumidify this space.
Right, and you may have been living with conditions that you're not aware of that are problematic, where your system is artificially making your bills more expensive because it's not running long enough, because the system is just too big. So it kicks on like a supercharged car, and it gets cold really quick, and it tells your thermostat, hey, I reached my set point, I've reached 65 degrees or 70 degrees, and it shuts off, but it hasn't run long enough to pull that moisture out of the air. So now you're kind of clammy, you're uncomfortable.
Which is, if you're having to run it down on 65, 70, that could be an indication of a problem right there, because you're having to run it down to such low frigid temperatures to be quote unquote comfortable, and you're still not fully comfortable in the space. If you have a system that's properly designed, properly sized, and can control the temperature and humidity in your space, you should be able to run that up on a little bit higher of a temperature, a more normal, stable temperature with a good humidity rating as well, and be more comfortable than you running it down as a refrigerator.
With the newer technologies, I've been in houses that are like 74 degrees, and I'm freezing. Mm-hmm. I mean, like you're at 65. I mean, just too cold.
Yeah, you get that crisp, cool comfort, right, instead of that clammy, just cold.
Correct. Now, another thing to understand is that the duct systems last as long as the air conditioning systems, but the duct system sizing 15 years ago was totally different than it is now. The equipment's a lot more efficient. It's designed differently. And you might be in a situation as much as 80% where the ducts are could be too small for the new system.
I'd say like 80-90% of the time we run across duct systems that are inadequate and undersized for systems. It's a very common occurrence. A lot of it was not just that the systems are in need of better designed duct systems, but duct design and performance, be it with the system and duct system, was not as well understood as it is today. So as the education and the technology and everything has changed cumulatively, it's come to light for a lot of contractors, builders, and home performance advisors that this is a known issue and needs to be corrected going forward.
So if you install a new system with a duct system that's too small, what's the impact there?
So if you're buying on value of, saving on energy, buying this, higher efficiency system that's supposedly going to be, 18, 20 SEER or whatever it is, or SEER 2, rather, and you put it on an inadequately sized duct system that's not performing well, I mean, you're not going to get that 18, 20 SEER 2 performance out of it, because it's as if you're running on a treadmill but trying to breathe through a straw. This system's now having to work even harder, and you're going to lose a lot of efficiency in that, and it can also lead to premature failure.
Yeah, that I was going to bring that up, because you get it may last 5 years instead of 15, right? Depending on how hard it's actually having to work to keep up. But so it's important that you deal with a company that is going to ignore what's in your attic. They're going to look at the house. They're going to look at the way the house is distributed, and then they're going to do their own calculations to say, look, your house needs a 3.5 ton. I know that you have a 3 ton up there, but it's too small for the space, and your duct sizes will work with this system, or your duct sizes are too small, and you're not going to notice any efficiency gains or reduction in your electric bills, because the system's going to work twice as hard if we don't replace the ducts that are designed for the system. So those are conditions you need to be concerned about, but they contribute to indoor air quality in this way. If the primary environmental control system is not removing adequate moisture from the space, then it's promoting microbial growth and other conditions, degrading materials and things like that wouldn't exist if the system was properly dehumidifying the air. Correct?
Right. There's a variety of factors. I mean, moisture control is definitely key to, foreign growth control. So that is key, especially in our climate where it is often very humid. But these systems, I know you mentioned, sometimes you have to go up in size. More often than that, we're finding oversized systems where we're actually coming back with capacity measurements much smaller than what is in the house now. So we're having
they're installing too much AC.
Yeah, everybody, bigger is better. Oh, it's not cooling, we'll put a bigger one in. And then now you have an oversized system on an already undersized duct system. So when we come in, typically that's what we find, and we end up, properly sizing the system, which is a lower capacity system, and then the duct systems that were already way inadequately designed, we have to step up to meet even that lower capacity system. And when doing that too, we look around the home and we ask, questions as far as what their comfort concerns are for different rooms and everything. And we can fix a variety of airflow issues in different areas of the house, different rooms, all that. So adding returns in key locations when we're redesigning this duct system, so we get the air changes in each of those rooms properly, and distributing the air properly, having dampers in the right, sections of the house and on each of the ducts, and properly sealing the ducts too, making sure everything's installed per the American Duct Council's, specifications. All those things play into part of the indoor air quality and the performance of your new duct system and your comfort system.
You don't want the old method to install a duct is they slap it on the collar and then they put a zip tie on it. Well, now they have this plastic or this mastic goop that's kind of a white cake, and it seals that termination for where that duct's connected. So you're not sucking all of that nasty, go up and look at your insulation in your attic. It's not sucking that stuff up in and distributing it around your house. So that's a big design change over the past 15 years to improve indoor air quality and the performance of the HVAC equipment. Now, let's get into a completely different category. Let's talk about air filtration, advanced air filtration. Everybody knows that, if you're dusting your house twice a week, then you need improved filtration. It's what you're breathing in it. The way that we've designed our homes and built our homes and the improvements that we're making to our homes now, it is all focused on sealing off the outside from the inside. Well, we didn't have indoor air quality problems before because our houses breathe like sieves. I'm sure you heard that. But when all the emphasis got onto, oh, we got to reduce our electric bills because we're consuming too much, the only way to do that is to seal off all of those air gaps so you create an independent environment from the outside. The problem is that we're humans and we still need fresh air exchanges for many reasons. And Terry's going to tell us some of those.
Yeah, so as we start building tighter homes and basically making these new environments, the home is still going to be producing a number of latent loads, which is moisture loads. So we as humans are going to be breathing, we're going to be showering, washing clothes, doing dishes, living in our space. And when we do that, we're going to accumulate a ton of particulates, VOCs, things of that nature, which your exhausts are going to take out a little bit of that, but if you're taking out air and you're not putting any air back, what's happening? Well, it's going to find somewhere to bring that air from. So any little crevice that isn't 100% sealed is going to start bringing it in. Well, now you're getting infiltration into your space, and it's unconditioned infiltration. So you're bringing stuff in from attics and between walls, from the outside, around windows, and this is poor air quality because this is just raw, unfiltered, unconditioned air.
Well, it's kind of like another good example is just put a bag over your head and try to breathe and see how long that lasts. I mean, you need fresh air in confined spaces.
Right. You don't want to overproduce, carbon dioxide and all this moisture and stuff and not have anything to dilute it or do anything with it. So we want to bring in, air, but in a mechanical way that where we can condition it. So we recommend supplemental ventilation through a dehumidifier. So whenever we do it that way, we bring in a column of fresh air at certain times and intervals, depending on the controls that we use. We like the Haven IAQ controller. It actively monitors outdoor air quality metrics and actually allows that dehumidifier and that fresh air to activate at key times to where we can bring in fresh air, run it through a MERV 13, which is a very, very good filter to filter out a lot of small particulates, dehumidify the air and condition it before putting it back into your space versus getting this raw unconditioned air from, every nook and cranny that, it possibly can.
Well, and if there's a vacuum, it will fill the vacuum, right? So that was more focused on the supplemental dehumidification and ventilation, which was the third category. But if you have an existing system and it's all fine, but you've got some conditions in the house where you are feeling these stuffy conditions, so to speak, the supplemental dehumidification technology that Terry was talking about and fresh air ventilation will help solve those problems so that it gets back to a normal, fresh, good feeling environment. Now, the advanced filtration filters is what we're talking about. A lot of people will run down to Home Depot or Lowe's and they'll buy what's called a HEPA filter, and it's 1 inch thick, and it's very, very dense. And they'll take the normal filter and just throw it away, and they'll stick that thing in there. That's a problem, okay? It does provide HEPA level filtration, but you can't accomplish that in that system with 1 inch of density. It's just not possible. It'll strangle the air conditioning system.
There's not nearly enough filter media, even in those densely pleated filters, to be very effective. And then you add to the recipe, a poorly designed duct system or leaky duct system or a system that utilizes old PSC blowers, which is only going to pull as hard as it can. You're just going to be backing off the performance further of your AC system and choking it down more. Once again, running on a treadmill.
It's like throwing a pillow in your duct system and say, okay, perform like you did before I did this, right? Bad practice. Don't do it. The MERV 13 filter is a category of filter, but it's much wider. It's like the width of your hand.
4 or 5 inches.
Yeah, 4 or 5 inches. But that system, that filter has to be installed up in the attic right before your coil because there's not enough space to put it in your return. So this will replace your return filter, and you only have to change it every once a year. But you're going to notice that your dusting will go down by like 75%.
Yeah, so media filtration is definitely something key, but you want to do it along with some other things too. You want to make sure that your duct system is adequately sealed and everything too, to limit the infiltration. And then whatever particulates are floating through your system, this media filter is going to be far more effective and superior to any 1-inch filter in getting those particulates trapped at that point, instead of just recirculating through your home and system. And it's also going to keep your system a lot cleaner, so cuts down a little bit on maintenance costs as well. So over the life of a system, if you're just using standard 1-inch filters, especially poly filters, I mean, those are good for catching, birds and bees, but not much else. So any kind of particulates are just floating straight on through. They're getting in your blower wheel, getting in your furnace, getting caught in your coil, making your coil dirty, and also lessening the performance of your system. So advanced filtration is not only going to increase the indoor air quality, but it's also going to save you on maintenance costs and protect, that big investment that you're making into your new system.
And one thing I love about Terry, he's very conservative in terms of the technologies that he recommends, because there's electrostatic filters. There's all kinds of these high-end expensive filters that can cost thousands of dollars to put on your system. And this is very, very inexpensive to incorporate in an existing system. You can have it put in today on each system, and it will improve the indoor air quality and your cleaning practices substantially. Not to mention, it'll provide improved smells. It'll take some of the smells that, some of the things that are creating odors in your home are being recirculated through the AC system, which can be filtered out with this filter. So it is definitely the most affordable thing you can do to have a substantial impact that won't restrict the airflow on your air conditioning system. So
with properly sized duct systems.
That's right. Terry, thanks for your time today. Thanks for joining us for Texellent Heating and Cooling podcast series. This is designed to help you understand more about the technologies that can help you and stay away from things that you don't need, like UV light bulbs. I forgot to bring up the UV light bulbs. Cover that real quick.
So UV bulbs are effective in certain applications. They are not to be sold or used as snake oil and some fix-all that's going to magically clean all of your air. The UV light that it puts out, and also depending on the intensity of light that you have, is only going to be effective on the surfaces that it shines on. So if
not the air moving in front of it.
Not the air moving in front of it, because it's not going to be effective at that. That air is moving at a very fast rate, and it's not going to be effective at sterilizing any of that.
Any disinfection application, whether it be chemical, UV lights, or what have you, require a dwell time. They have a certain period of time they have to be exposed for it to produce the kill, and high flow air movement in front of a light bulb is just not going to cut it.
No, so they're only going to be effective at if you put it in front of an evaporator coil, possibly keeping the surface of that coil clean by sanitizing that surface, or possibly a high intensity bulb in a plenum could potentially keep a lot of that clean, but that light has to shine directly on it and continuously. And a lot of the times, just depending on where it's installed and if there's any shadow in there or anything that cuts off that light from any portion of it,
if it can't see it, it won't kill it.
Exactly. So it's not
called a shadowing effect. Yeah,
it's not the most effective thing. The most effective thing is proper system design, proper duct design, sealing procedures that are effective, and proper dehumidification, and making sure your system is performing like it's supposed to in the first place.
All right, so if you want to get a hold of Texellent Heating and Cooling, call them today at 281-402-5100. 281-402-5100. You can find information online at texcellentacservice.com.
Thanks for listening to the Texellent Heating and Cooling Podcast. Located in the Deer Park area, contact Texellent today at 281-402-5100 or texcellentacservice.com.